Good morning to all. Myself Pradeep Kumar Swain, lecturer in mechanical Gauss cutter. Today we will discuss one of the machine tools. There are many more machine tools, that is lathe, milling, shaper, slaughter, many more machine tools. But today we will discuss one of the machine tools, that is milling machine. So first we will see what is milling. Milling machine is a machining process or material removing process in which we use multi-point cutter. To remove the material. That is, workpiece is fed against a multiple cutter so that the material is removed. So milling is the machining process in which removal of metal takes place due to cutting action of a rotating milling cutter. The milling cutter is used here, multi-point milling cutter. So that in other machine tools we use single point cutting tools, but here we use multi-point cutting tool so that material removal process is very fast. So it is used in production process. Next, the machine can also hold one or more number of cutters at a time. Thus, the milling machine is one of the most important machines in the workshop. The metal removal rate is high as compared to a lathe machine because we use multi-point milling cutter. Then we will see different parts of a milling machine. Following are the parts of a milling machine, that is base, column, saddle, table, overhanging arm, front brace, spindle, arbor. Then we will discuss what are the different parts of the machine. This is the milling machine. This is one type of horizontal milling machine. Here the different parts are base, column, spindle, overarm, spindle, arbor, cutter, table, saddle, knee, elevating screw. So first we will see what is base. Base is the main supporting element of the other supporting parts of the all other parts of the milling machines. Here base is made up of grey cast iron. Why grey cast iron? Because because if we use grey cast iron, it has high damping capacity. That means if there are more vibrations, then this base is absorb these vibrations. Why? Why? Because base having more damping capacity. Here sometimes also in some milling machines, here base is made hollow. Why? When cutting fluid is used, cutting fluid is stored in base. Then column. What do you mean by what is column? What is the functions of column of these milling machines? Now this column supports all other elements of the milling machines. This column is made up of a hollow rectangular cross section or square cross sections. Because in hollow parts, all other gear elements for moving this saddle and table is saddle and spindle motions. For operating saddle and spindle motions, more number of gearing element is used in column. Because the base, as we told, the base of the machine is of grey cast iron and serves as a foundations member for all other parts which rest on it. The base carries the column at its one end. In other machines, the base hollow and works as a reservoir for cutting fluid. Here, base carries column and column supports the overarm. Then column. The column is the main supporting frame mounted on the base. It is a box shape and houses all the driving mechanism for the spindle and feed table. The front vertical face of the column precisely machined and is equipped with dovetail guide wedge for supporting the knee. Means this column carries the dovetail mechanism for knee to move up and down. To move the knee up and down for adjusting the various heights of workpiece. Then the knee is fixed grey casting that sides up and down on the vertical edge of the column face. Why knee is provided and why dovetail mechanism is provided in the column? Because if we will use dovetail mechanism, the knee will move up and down to adjust different heights of a workpiece. Then the adjustment height is affected by an elevating screw mounted on the base that also supports the knee. The knee houses the feed mechanism of the table. Then the feed mechanism of table means the table can move longitudinal motion or cross motions. These mechanisms are arranged in a knee. Means all supporting arrangements for moving the table is placed on the knee. The top face of the knee forms a slide wedge for the saddle that gives cross travel to the table. Means the upper part of the knee there is a saddle. Means the upper part of the knee bears the saddle. Then we will move overhanging arm. Overhanging arm acts as a support for the arbor. What is arbor? Now arbor means it is the extensions of this is the spindle, but in horizontal milling machines, the spindle is stopped here, but extra part, this extra part is called arbor. Arbor is used. Why arbor is used in horizontal milling machines to flash the cutter or to hold the cutter. Then spindle. The spindle is the main machine, is located in the upper part of the column and receives power from the motor through belt, gear and clutches and transmitted it to the arbor. Means this arrangement was supported in column. These arrangements for spindle motions was placed in the column, was placed in the hollow column, this belt gear. The front end of the spindle just projects from the column face, means in the column. Means this is the spindle. From this arbor was attached to hold the cutter. Arbor. Then arbor is an extension of the machine spindle on which milling cutters are securely mounted and rotated. Arbor is used only in horizontal milling machines, but vertical milling machines there is a spindle. In vertical milling machine for holding the cutter there is a spindle, but in horizontal milling machine arbor is used to hold the cutter. This is the difference between horizontal milling machine and vertical milling machine for tool holding. These are made with the taper shanks for proper alignment with the machine spindles, having taper holes at the nose. Then the arbor may be supported at the farthest end from the overhanging arm or may be of cantilever type, which is called stub arbor. Means if we use, suppose in overhanging, suppose stub arbor, this is the arbor, if arbor is used in long, if this is long, called arbor, but if short, this is called stub arbor. This is called stub arbor. Then working principles of milling machine. What is the working principles of milling machine? Milling machine's working principles. The working principles of the milling machine applied in the material removing operations on a milling machine. The work is rigidly clamped on the table of the machine and revolving multi-teeth cutter mounted either on a spindle. The cutter revolves at a normal speed and the work feeds slowly past the cutter. Working principles of the milling machine means first there is a rotating multi-point cutter. First, there is a rotating multi-point cutter. This is a multi-point rotating cutter. This is arbor and this is cutter. Arbor and this is cutter. Suppose milling cutter is rotated in clockwise directions. Then if we place this workpiece, in these directions, then what happened? The cutter, then this teeth of the milling cutter removes the material from this workpiece. Means work is fed against a rotating multi-point cutter. Means work is fed against a multi-point rotating cutter. Then material is removed. This is the working principles of milling machine. Then we should know different methods of milling machine. Then methods of milling machine. This is the working principles of milling cutter diagram. This is the different teeth. If we remove this cutter, if we rotate this cutter, then the multi-point cutting teeth of the cutter removes the material from this workpiece. This workpiece was placed on the table. This is the working principles of milling cutter. Then we know the methods of milling cutter. Methods of milling machine. Then methods of milling. Methods of milling. Milling method. There are three types of milling methods. There are three types of milling method. One is peripheral milling. Second is face milling. One is peripheral milling. Second is face milling. Third is end milling. Then third is end milling. Then third is end milling. First one is peripheral milling. Second one is face milling. Third one is end milling. Then first we will discuss one by one. Then we will see what is peripheral milling. First we will see what is peripheral milling. Peripheral milling. What do you mean by peripheral milling? Peripheral milling means if we produce a flat surface parallel to the axis of rotation of the cutter. If we will produce a plane surface on the workpiece parallel to the axis of the milling cutter, this is called peripheral milling. Means here the cutter axis is parallel to the milling surface. Parallel to the milling surface. Here one disadvantage of this peripheral milling is the cutting force throughout the surface is not even. The cutting force throughout the surface was not even, so that there are many more vibrations and rough surface may be produced. So again, peripheral milling is divided into two types. First one is off milling. First one is off milling or conventional milling. First one is off milling or conventional milling. Second one is down milling, second one is down milling or climb milling. Then peripheral milling means cutter axis is parallel to the plane milling surface. Plane milling surface produced. Then this peripheral milling is divided into two types: up milling or conventional milling. Second one is down milling or climb milling. Again we will see these two types of milling: up milling and down milling. What do you mean by up milling? Up milling means as the working principle of milling machine is if we feed the workpiece against a multi-point milling cutter, then up milling means the cutter direction and work feed direction both are opposite. In up milling means up milling or conventional milling the workpiece feed directions and the cutter directions both are opposite. Means if this is a cutter, means if cutter rotates in this directions, clockwise directions, if cutter rotates in clockwise directions, means workpiece should be fed against this. Workpiece should be fed opposite to this, means workpiece feeding direction is this. Means these directions and cutter rotational direction, cutter rotates in clockwise direction, means these actions both are opposite. Cutting actions and feeding actions both are in opposite directions. So this is called up milling, means opposite directions. Then what are the advantages and disadvantages of these milling actions? Up milling. In up milling, what was happened? At the starting point of this up milling means when the cutter teeth and workpiece first starts to contact, there is a heavy thickness. This thickness varies from maximum to minimum. This thickness varies from maximum to minimum. For this, what happened? There is a heavy force. This force may lift this workpiece. This force may lift this workpiece from machine table to upwards. In this case, a rough surface was produced. Rough surface is produced. Heavy vice is required. Why? For this upward motion of this cutter, this from maximum to minimum, there is a chance that workpiece may be lifted from the table. For this, heavy vice is required and rough surface was produced. But in case of down milling or climb milling, what in case of down milling or climb milling? down milling or climb milling, but in case of down milling or climb milling, if this is the cutter, if this is the cutter, milling cutter, if we rotate in clockwise direction, down milling or climb milling, both the directions of the workpiece and cutter directions are same. But in up milling, both the directions means feeding directions of the workpiece and cutter direction, both are cutting actions, both are opposite. But in down milling or climb milling,